Assalamualaikum and good day. I am Anisha Kira binti Abdul Jalil, and today I want to present my final year project entitled The Variability of Water Turbidity and its Dynamic Factors at Straits of Malacca. This is my introduction. Turbidity is a measure of decreases in water transparency because of suspended materials. Turbidity influence the penetration of light in the water column. The measurement unit for turbidity is nephelometric turbidity (NTU). High turbidity could affecting the water quality and environment. Turbidity is influenced by both ocean physical processes such as ENSO and IOD, and also physical variables such as SST and wind speed. The problem statement for my study is the analysis method for this study required secondary data as it comprised the long-term period of data collection. So, the in situ method is not compatible for this such of a case study. These are the objectives for my study. First, to determine the long-term seasonal and interannual patterns of water turbidity in Straits of Malacca. Second, to determine factors that influence the water turbidity in the Straits of Malacca. Next is the methodology. First, my study site is Straits of Malacca. It is a waterway that connecting Sea Andaman and South China Sea. Straits of Malacca is a narrow stretch that runs between the peninsula of Malaysia and Sumatra Island. The area of interest for Straits of Malacca is 0 until 9 degree north and 95 until 104 degree east. This is the methodology for my data analysis. First, the data is downloaded from the sources, which is MODIS and CCMP wind speed data. The MODIS data is obtained from Aqua and Terra satellite from Ocean Color website. Second, subset the data of MODIS and CCMP in software, which is RStudio and R software. Third, Aqua and Terra data is merged. Fourth, resample CCMP wind speed data to 4 km in the software. Next, the water turbidity is calculated. Then, masking the data by using the function of Dyn-Off algorithm. The missing data is filled in. Next, calculation of monthly and yearly anomaly of turbidity. Calculation of monthly and yearly anomaly of SST and wind speed. And then, the spatial and temporal distribution of turbidity is calculated at three regions of Straits of Malacca, which are north, middle, and south. And lastly, the spatial impact and interrelationship of turbidity with other physical variables such as SST, wind speed, IOD, and ENSO is calculated. This is the result from the calculation of the yearly anomaly of water turbidity. The figures show the yearly anomaly of water turbidity at Straits of Malacca from 2002 until 2020. Okay, this is the final result from the CWT analysis and also discussion. The figures show distribution of water turbidity ZST at three regions of Straits of Malacca from year 2002 until 2019. Uh, the color bar on the right side represents the amplitude of the wavelet, where the blue indicates low power signal and the red color indicates high power signal. Next is the correlation of water turbidity with SST at three regions of Straits of Malacca from year 2002 until 2019. Based on the figures shown in the result, it can be seen that between 8 until 16 months from 2002 until 2019 at Straits of Malacca, the arrow in the plot is pointed downwards. This shows that ZST and SST has an inverse relationship where ZST is led by SST. In the year of 2005, between 1 and 4 months, the arrow pointed to the left indicates that when ZST is high, SST is low and vice versa. This is called outphase. And between the year of 2014 and 18, there is an arrow pointed to the right side indicates a linear or direct relationship between the ZST and SST during that period. Okay, this is the correlation of water turbidity with WSPD wind speed at the Straits of Malacca from year 2002 until 2019. Based on the figure, there is not much correlation can be observed. In year 2005, it shows that the arrow pointed up left, where it indicates the ZST is led by the WSPD wind speed. Thus, ZSD happened when wind speed occurred first. In the year of 2015, there is a lag correlation where ZSD lead WSPD. In 1 until 4 months, there is high signal power the whole year, where the color is ranging between orange and black, which means the coherency between ZST and WSPD is relatively strong. And this is the result of correlation of water turbidity ZST with ONI and the MI index, which is ENSO and IOD ocean physical processes at the Straits of Malacca from the year 2002 until 2019. As a conclusion, the direction of arrow in every plot shows the type of correlation between the series. Right pointed arrow indicates positive correlation or in phase, and left pointed arrow indicates negative correlation or out phase. There was a negative and positive correlation between ZST and SST in certain period of time. The correlation between ZST and other physical variables such as wind speed and also IOD and ENSO shows the same pattern at the three regions of Straits of Malacca. And this is my reference. That's all. Thank you.